Welcome back to the channel, hope everybody's doing well, and in today's video we are taking a look at the Lexxi T1660 time domain reflectometer from Radiodetection. This is my own unit. I purchased this a little while back as part of the basic kit. You obviously get the meter itself. It does come with a set of AA cells, takes 6 AA cells that go inside it. It does come with those. You get a 100 ohm twisted pair lead with the 4mm bananas on the end that go into your instruments, and then crop clips at the other to connect to the cable or whatever you are testing. You do get a small little instruction leaflet with it, which is just very much your basic operation guide to the instrument really. If you go on the Radiodetection website, you can download a slightly larger manual for this that gives you a bit more detail of its operation. And then you get a carrier bag to put all this in. You get a pouch at the back here to put all the leads in. Now this is velcroed onto your main case, so you can take this away should you want to, or you can leave them coupled together for a bit more security. You can connect them with those two press studs as well, and then you can close the whole case up a little bit better with these two straps that go over the top and onto the press studs. And then you do have a carry handle here, and as you can see we have a big front screen, so you can actually put the instrument inside the case, and then you can actually operate it like this with it housed within the case. You can get to the instrument easy enough and control it all, and then just put whatever lead you want in at the top with the top open. Protect the instrument a little bit should you like to do that. The case is okay. Always strikes me as a little bit of a cheapo case. It's this kind of canvasy fabric. It's fairly thick, but I don't know how long it will last, whether it will split at the seams as those kind of cases seem to do in my experience. We shall have to wait and see. So that's what you get in the basic kit. That will cost you around about £1,000 today. Now alongside the basic kit I did purchase a mains blocking filter with this as well, so this allows you to connect up to live mains should you want to do measurements on those circuits. That would be a handy feature. The filter slides into the back here somehow or other, it does, honest, and then plugs in, and then you can connect to your live circuit with fuse test leads as well. So that's that there. That blocking filter on its own is around about £250. You can get a couple more options to go with this as well from Radiodetection. A 50 ohm twisted pair lead with this, and a 75 ohm BNC adapter as well. I didn't buy those, so I don't know how much they are, but they are available should you want them. So TDRs in my game are used. They can be used for cable fault detection. Not so much for me. I tend to use these on setup for partial discharge measurement systems where we have two couplers installed per phase. We measure the time differential between those couplers so that the machine, when it takes the measurements, can then calculate the direction of the partial discharge pulses and whether they're coming from a machine that you're testing or in actual fact a system, buzz bar or transformer, something like that. So this is primarily what I will use this instrument for. Very, very basic to use. We will bring in our little cable here. And this is just a coax cable. We can test this with other instruments as well, but it will go nicely with this little TDR for a demonstration. So fairly basic instrument to set up. If we go down to our settings and select that, there's not much you can change in this unit really. We have meters, or we can have feet. We can go down, we can get velocity of propagation, which we have 11%, or we can put in meters per microsecond. There are two options for that. We have screen brightness, we have high, low, medium, shutdown time. I'm not sure what this goes to. Save in a minute. There you go, and then we can go to languages as well. German. Yeah, I'm probably going to regret doing that when I just go back there. So there's the different languages that you can have with the instrument. and we can go back to that and leave it all as it is. We can also set the battery type. I presume this is just for the actual battery level measurement there. You can set it to either an alkaline or an NIMH cell. And finally, obviously, we go to measurements. And the typical display of any TDR with the initial pulse up there, because nothing is connected to it. You can test our wee little cable out here, our coax cable. And plug him on the end. Now I do know that this cable is 6.6 meters long, having physically measured it. We can, our velocity of propagation up there, we leave to 66%. That's just because this is an RG58 cable, and from the datasheet for an RG58 cable, the velocity of propagation is 66%. So we leave him set where he is, but you can up and down it should you want to, just with the arrow keys. It's not a problem. Obviously you have to set that correctly in order to get an accurate distance measurement on your instrument. To go down through the next setting, you hit the selection button there, and we can change this to 50 ohms, 25 ohms, 75 ohms, 100 ohms. So you just have those options there for the termination. We're on a 50 ohm cable, so we can leave them as that. And then next select gets you down there, which is on the range. We are currently on a 30 meter range. You can see we are below half a screen, so I can change that down to 15 meters to give it slightly better. Or we can go to 30 meters. I think this has a total of 6 kilometer max range, so we have quite a range to go up to. There's our 6 kilometer up there. The downside to this is that you have to, once you've gone up to the range, you have to use the down arrow to go back down. It doesn't cycle its way around. So we are on 15 meters, 7 meters there. Like that is it. Let's go up to 15 meters there. And then our final one is our gain that we can change should we need to. On ×1, you can put this up as much as you. Obviously, on our screen there, we started to cut off the top of the waveform, which is be a bad setting, but you can keep going up to ×8. Again, it doesn't cycle its way around. You've got to go back down again. ×1 there. So you can see, if I can set this up right, where would we be? That's the bottom of the waveform that we've got there. You can use the cursor keys here to move the little red band across, and there it gives you the length of your cable is 6.54 meters. It has a plus or minus 1% tolerance, and that would be a 60 centimeter tolerance on a 6.6 meter cable. So we are just within that tolerance band, aren't we? With that set in there, we can, because this is a set of parallel cables for my air gap search coil test apparatus, we can link these together should we want to. Do it that way, and then we should double our cable length. So now obviously we've gone over our 15 meters. We are just, you might just kick it in at the end there if we go all the way across. So let's just go back down 15 meters. We put that up to 30 meters, and then we get a better idea then, don't we? I think this lead might have a dodgy connection with it. We're on 12.6 meters there by the looks of it. And we would be 13.2, wouldn't we, with the 6.6. That seems to be a little bit out with regard to that. Well, what we can do now is, once we've got our connector in there, this is obviously halfway, so we put a resistor bank in here, and we can put our little adapter lead in there. Still okay. So this would now be a dead short right at our halfway point, which if we go back there, It would be somewhere around about there, it's thinking. What we can do is change to our 15-meter range. Oh, that's not good. For that for. So we'd be looking at a fault somewhere around about 7.11 meters, it seems to think. Doesn't seem to like it when you go down to 15 meters, do you? Guess you would be going over there. Would be your first point of dip, which is looking around about 6.85 meters now. We need to go back to 30 meters. So that's what we get with a fault halfway. I start to change that fault and put some kilo ohms into it. You can see it picks up the end as being open circuit as the predominant, but we still do get a little indication down there on the fault. But that's 1k, that's 2k. Doesn't really change. 100 ohms, still a noticeable dip. Go the other way, 100k. Still kind of noticeable. And I want 100k, 1 meg ohm. So it does seem to pick up a fairly high fault. That's 10 meg ohms. It's just not as visibly clear. And obviously, if you had a longer cable going over there, it wouldn't be so obvious that you had a fault, depending on what was occurring elsewhere along the cable length, of course. But yeah, that's a quick look at our little Lexxi T1660 time domain reflectometer from Radiodetection. That'll be it for this video. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next one.